Greetings, engineers. We are the Group 4 of the course Ergonomics 1. We're assigned to report and help you understand the auditory sense, noise and its health effects, and also the noise measurements. But first, let me just introduce you the team behind this report. First reporter would be Leonard Gay Manatod. Second, Ryan James Garcia. And third, John Kennedy Blanco. Here are the table of contents of our report. First, objectives of the report. Second, introduction. And third is the body of the report. Fourth, video links and examples to the topics. And the last one is the summary and conclusion. And these are the objectives of our report that we want to portray. Our first objective would be to define the differences between noise and sounds. Second objective would be to understand the effects and hazards of noise to human health. And the last one is to discuss noise measurements. Here is the introduction for our auditory sense report. Another component of the human senses is the auditory sense. It allows us to hear things, sounds, noise, listen to music, and etc. In this lecture, components of sounds and auditory sense will be discussed. Our auditory sense is important to us since it will allow us to hear or perceive signals through air vibrations. In workplaces, adequate sound level are considered and too much noise will be dangerous for the workers. In ergonomics, audition is one of the factors to identified and incorporated in your design. Body of the report and its contents.
Greetings everyone. My name is Leonard Gacy Manatad and I will report the definition of terms. Our definition of terms are words that give you an understanding of the topic that will be discussed. First is sound, which are vibration that travels through air or medium. They are heard when they are reach the ear. Second is noise, unwanted sound that cause annoyance and disturbances. Next is frequently, which is also called pitch, the number of times a sound wave repeats itself, measured as hertz, a sound wave with high and low. And finally, the wavelength is the linear distance traversed by sound waves in one complete cycle of vibration.
Greetings everyone, I'm Blanco John Kennedy, also reporting for auditory sense, noise and its health effects, and noise measurement. Measurement of noises. Noise level is measured in decibels. The louder the noise, the higher the decibels. Decibels can be adjusted to human hearing. Decibel. So what is decibels? It is a unit for expressing the ratio between two physical quantities, usually amount of acoustic or electric power, or for measuring the relative loudness of sound. Most common metric applied to quantification of noise. Measure of sound level. Referring to figure, sound pressure level is in decibels and pascals for typical sound. Any noise level between 60 decibel may cause annoyance. Rates are imposed when the sound level reaches 70 to 90 decibels. And all noise level above 90 decibels can cause danger and damage to hearing. For example, the sound sources that exceed this threshold include familiar things such as power lawn mowers with 90 decibels, subway trains with 90 to 115 decibels, and loud rock concert with a range of 110 to 120 decibels, and many more sounds that we may encounter in our everyday life.
The four major priorities of sound. One is frequently. This is the element of sound that we are best able to distinguish. We are mesmerized when a singer reaches a particularly high note at the climax of a song. Just as we are, when a dancer makes a spectacularly difficult leap, we feel very low in way the physical as well, sometimes experiencing dark or somber sentiments. For the number 2 is the sound pressure. It is the average variation in atmospheric pressure caused by sound. Differences between instantaneous pressure at the point of presence of a sound wave and static pressure of a medium measured in decibels. For the number 3 is the sound power. It is the total airborne sound energy radiated by a sound source per unit of time, and the rate which sound energy is emitted, reflected, transmitted, or received measured in watts. Last is the time distribution. It consists of synchronizing a network of clocks over one or more building using a master clock and a measure of how much time a matter spend in it.
Instruments used to measure noise. Number 1 is dosimeter. The audio dosimeter is a portable battery-powered device used to obtain special measure of noise exposure. What does the dosimeter do? A radiation dosimeter or badge does not provide protection but detects and measures radiation that you have been exposed to. The badge will detect the high energy data or gamma or X-ray radiation. What is the most commonly used dosimeter? Optically simulated luminescence or dosimeter. This is the most common type of personal dosimeter used in monitoring of occupational radiation exposure in diagnostic radiology today. This type of dosimeter is lightweight, durable, and easy to carry. Second is spectrum analyzer, advanced sound level meter that breaks down noise into a frequency components. A spectrum analyzer measures the magnitude of an input signal versus frequency within the full frequency range of the instrument. What is a spectrum analyzer used for? A spectrum signal analyzer measures the magnitude of an input signal versus frequency within the full frequency range of the instrument. The primary use is to measure the power of the spectrum of known and unknown signals. So those are the two major instruments used in measuring noise.
Next online will be the Noise Safety Formula, or HLP, which means Hearing Loss Prevention. It helps assist in computing noise level around a certain workplace. The formula for this would be D equals the quantity of C1 divided by C1 and so on and so forth times 100, where D is equal to dose, C is equal to actual allowable time, and T is equal to allowable exposure time. Let us see the representation here on the table on the screen. Table 1, allowable noise exposure. And the measurement that used on this table would be the decibels, the noise level, and also the allowable time exposure. If you have an 85 decibels, the allowable time exposure would be at least 8 hours, and 90 decibels 4 hours, 100 decibels 1 hour, 105 decibel 30 minutes, 110 decibel 15 minutes, and 115 decibels would only 0 minute. And if for example you are using your earphone to listen to a sound, and that earphone would be 85 decibels and up, if the earphone would be having the 85 decibels, the allowable exposure time for that would be at least 8 hours only. And if we're exceeding on the 8 hours, we will be experiencing health effects that we will be discussing later on. The risk of hearing loss increases dramatically as noise level increases. Exposure to noise levels above 140 decibel will cause immediately damage to the nerves in your ears. Example number 1. Assume an employee is exposed to a 92 decibel scale for 8 hours. Compute the employee's noise exposure, the time weighted average, and what action, if any, would be required of the employer. Exposure. The exposure time is 8 hours. The represent duration for 92 decibel scale is 6 hours. This is equal to 100 times the quantity of C1 over T1 close parenthesis equals 100 times the quantity of 8 divided by 6 close parenthesis equals to 133%. Here is the table used to determine the reference duration of the 92 decibel on the problem that I read earlier. Alright, here we go. In the table HT2, find the values for 130% and 140%. I will be flashing the table now. Here, the value of 130% is 91.9 and the 140% is 92.4. Alright, the difference in the time weighted average values 92.4 minus 91.9 is equals to 0.5. Since 133% is the one half of the way between 130 and 140, 130%, which is the value that we solved earlier, equals to one half or 0.5. We will be adding the 91.90, which is the value of 130%, plus zero point 0.5 equals to 92.4 decibels in scale. And this is the action should the employer do. Since the employee's exposure is above 90 decibel in a scale, TWA 8, the employer would be required to institute a full hearing loss prevention program, including controlling noise as feasible and providing hearing protection and training for employees.
Health effect of noise. Repeated exposure to loud noise can lead to the bad effect on our health. Permanent hearing loss is a person loses the ability to hear higher pitch first, and it's commonly caused by long-term exposure to the loud noises. Next is tinnitus. In the term of hearing sound that came from inside your body rather than from outside source, a permanent ringing, whistling, roaring, or buzzing in one or both ears. Next is acoustic trauma. Damage to the hearing mechanism within the inner ear or immediate damage to the ear from immediate loud events such as explosion. Next is noise-induced threshold shift is referred to auditory fatigue and temporary loss of hearing sensitivity. Next is hyperacusis. It's a disorder in loudness perception. Patients suffering from hyperacusis may appear overly sensitive to a range of sound, finding many noises unbearable and painfully loud. And finally, non-auditory health effects are psychological problems such as hypertension, heart irregularities, extreme fatigue, and digestive disorder. And also, most of the psychological disorders are related to the stress caused by noise and annoyance.
Hearing protective equipment. Earplugs. Earplugs are made of foam, rubber, or plastic and are either one size fits all or in sizes small, medium, and large. Some are disposable, some are reusable. They are lightweight and require no maintenance, and they are inserted into the ear canals. Ear muffs cover the whole ear and are preferred by some people. They have replaceable pads in some high-tech styles, filter out specific noise pitches. They last longer than most plugs. Ear cups ears. Cups are like earplugs, except they do not go into the ear canal. They only block it. They are good for occasional use or for people who find earplugs incomparable. They are not as protective as the earplugs or maps. Summary of the report. The auditory system transforms sound waves into distinct patterns of neural activity, which are then integrated with information from other sensory systems to guide behavior, including orienting movements to acoustical stimuli and intra-species communication. The first stage of this transformation occurs at the external and middle ears, which collect sound waves and amplify their pressure so that the sound energy in the air can be successfully transmitted to a fluid filled cochlea of the inner ear. And to wrap things up, the noise will turn into noise pollution, a very dangerous problem that the Earth or our Earth is facing these days. And the auditory sense is a study of sounds in ergonomics on how much level of the noise using special equipment or devices. However, there are some possible ways to reduce sound or noise pollution. First is the planting trees on both sides of the road and highways to reduce noise pollution around hospitals, schools, colleges, and houses. Second, driving vehicle without silencer should not be allowed and loudspeaker should not be allowed anymore. Lastly, factories should be constructed far away from houses and schools and unnecessary honking of vehicles should be banned. Furthermore, I believe that there are also ways to take care of your sense of hearing, such as don't listen to the volume in your music player, using earbuds to reduce sounds or noise from outside when you are at work, reducing loud signs in your room, have regular hearing tests, keeps your ears dry, don't use any shape things or sharp things to your ears, and keep the volume low when you're watching TV or playing game. Alright, that's all engineers. We're done with our report. And thanks you for listening. And I hope I understand or you understand our report.